So this is just a short video for the Introductory Maths for Chemists on units. So this is me, I'm Fiona. I'm 1.60 and today I walked 7.84 and have burnt 2,577. When I was a billion, I celebrated with 6. I like light of 489 and my favourite element is ruthenium, which is a molecular mass of 101.07. Doesn't really make a huge amount of sense. What we need to have is we need to consider the units. So think about it again, but in terms of units, and it starts to make sense. Of course I'm not 1.60 miles, monkeys or anything else tall. I'm 1.6 metres tall. And, you know, I surely haven't walked anything like 7.84 hours. It makes sense if it's kilometres. 2,577 toasties would be a really bad day at the office, but calories make so much more sense. 1 billion microns? Worshippers? You know, we've got to think of these things in terms of what makes sense. So 1 billion seconds. I'm making what makes sense by using a unit. So when I was 1 billion seconds old, what did I celebrate with? Well, I celebrated with 6 Star Wars movies. When I was 1 billion seconds old, there were only 6 Star Wars movies. I like light of 489 candles would be romantic, but actually 489 nanometers. For me, it's a really beautiful blue. And actually getting to a chemistry example, the molecular mass of ruthenium is 101 grams per mole. Okay, I've just spent a rather silly few minutes basically saying that to make sense of any quantity, it should have a unit attached. There are some units in chemistry, or some quantities in chemistry that don't have units, but usually things belong to units. Now, there are a few basic units that we use, and these are called the SI base units. The SI, or the System International, lists 7 units from which all of the units are derived. Scientifically, these are the units we go around using. Now, these are the units of meters for length, seconds for time, kilograms for mass, amps for electrical current, Kelvin for temperature, moles for the amount of a substance, and candela for luminous intensity. And you can see the symbols here. Now, in practice, even though I've been a scientist for half of my life, I've actually only ever used 6 of these. I've never used a candela as a unit in the wild. But meters, seconds, kilograms, amps, kelvins and moles occur all the time in chemistry. In fact, the mole is probably the chemist's most unique unit. Very few other people will use the mole quite so much as we will. Now, when we're thinking about units, sometimes it's not convenient to talk about the quantities that we're after with the numbers that might be attached. And so we can modify our units by using something called prefixes. Prefixes are when values are very large or very small, and we use them to make things easier. And I've highlighted a few here, deci, centi, milli, micro. These are our everyday. So I can modify any of the quantities before. Meter can be a decimeter, centimetre, millimetre or a micrometre. You will have heard of any of these. But we can do exactly the same to the amp. I can have a deciamp, a centiamp, a milliamp or a microamp. Now, there are a few others that I think are important. And they are nano, pico and femto. From my point of view as a spectroscopist, I use nano all the time for wavelength of light, nanometers. And pico I use a lot because it's a time duration that matters in my research. But also so does femto. A very, very short time is usually how I consider a femtosecond. But if you want to think about femto in terms of a distance, the nucleus of an atom is usually a few femtometers across. One other unit that perhaps is important, or prefix which is important, is the kilo, the big side. We use this all the time for kilojoules per mole. But For those of you that have perhaps paid attention to hard drives in the last few years, or file sizes on your computer, megabytes, gigabytes, terabytes, and even petabytes are commonly used big prefixes. The point is, I can adjust any quantity, any unit that I have by using these prefixes to just make them easier, to make the numbers I'm handling easier. Now, the 7 base units I have, amp, mole, kilogram, and the rest, actually combine in different ways to make all of my other units that I should be using. The most commonly used units in chemistry are probably some simple things like a joule. And a joule is made up of a kilogram, metre squared, per second squared. Electrical charge, for people who do electrochemistry, is an amp second and has the unit coulomb. Force, when we're trying to apply a force to compress a gas or something like that, is measured in newtons, and a newton is a kilogram metre per second squared. You'll also come across velocity when you look at mean speeds of gases, and molar entropy, which doesn't have a fancy unit title. But then we've got other things like frequency and potential difference. We can see these are all just made up of using these different base units. I'll go into more of this in other videos, but so far, I hope this helps.